All right, here we are again after it seems like a long time, doesn't it? That's right. Okay, so here's what we have to do today. We're going to be looking at the sample midterm. And let's see. As far as the material goes, we're in chapter 7. Our discussion about taxes and other government interventions in the marketplace. Let me just get that open. Yeah, I think we had just about finished. Yeah, I think we were finished with this consumer surplus and producer surplus. We were just looking at getting ready to look at taxes in 7B. No, that's 7. Okay, that can't be right. Hold on. Oh, wait a minute. There we go. We hadn't quite started the discussion about taxes yet. All right, that's good. So we'll save that for after we're done looking at the sample midterm. Now, the sample midterm is based on the first few chapters of the course, 1 through 4. That actually 3, 4, and 5. That's right. So let me get that out right now. And so what's happening here is that the sample midterm is sort of like the prelude to the actual midterm. And so once we're done with this, I can post the actual midterm. And let's see, today's Friday, isn't it? Yeah, why don't we do this? And this is what I've been doing in all my other classes. Even though these exams aren't really that long, let's try. Let's take a look at the calendar for a second. I've been giving everybody a week basically to get these take-home exams done. So since today's the 12th, let's see, maybe you could have it ready by maybe next Friday at, let's say, midnight. That sounds like a plan. That's a full week, including a whole weekend. And the test isn't really, like I said, it isn't that long. It's very similar to what we're doing in the sample midterm. And it's just based on 3, 4, and 5. And you'll take it home. I mean, you'll download it, of course. You'll do it at home, most likely on just regular paper. And then what you can do is take a picture of it with your camera on your phone, of course. I mean, unless you have a really good camera. Or you can also, if you have a printer, you might have a scanner attached to it. You can use that as well. The scanner can turn your documents into a PDF document, and then you can email them back to me as well. But either way, what I'd like you to do is 2 things. Number one, if you can remember, not that it's mandatory or anything, but it would be nice if you could send it to my Manhattanville email address, only because it makes it easier for me to keep them all together. If you send it to my regular email account, it'll get mixed in with lots and lots of other emails, as you can probably imagine. But here, it'll all be just one nice big, yeah, that's the wrong one, isn't it? Yeah, just try to send it to my Manhattanville account. Okay, let me just quickly fire that up. Okay, so for example, do I have any emails here? Yeah, so if you send it here, I'll just send one to myself real fast. I'm just making sure that the thing is working. You never know with emails. All right, now you see what I mean? This is so ridiculous. So I sent it. And now whether it arrives or not is a different matter altogether. There it is. Okay, so you can feel free to use that email address. If you saw me doing it, it's alan.anderson, there it is, at mville.edu. Okay, And if you forget, it's not the end of the world, but try to remember to send it there. Also, when you download all the files, of the picture files, I mean, just take a good look at them. Make sure that they're legible. That can be a problem when taking pictures of documents. If you're not careful, it's easy to make it hard or impossible to read. And especially if you're using pencil, try to make sure that it's as dark as possible, because sometimes pencil doesn't photograph well. It comes out very, very faint, and it becomes next to impossible to read it. And also, if you're going to be saving these files anyway, if you could put your name in the file title. In other words, instead of having a file like IMG 3321, if you could retype that with your name in it, that could also be very helpful to me to help organize all of them, because there's going to be a lot of them, and I'll have to have them all organized correctly. I do not want to lose anyone's exams, but unlike a handwritten exam where I can at least figure out who you are from your handwriting, if your name isn't on it, with these, if there's no name, I don't know who you are. Okay, so try to the extent that's possible, remember to put your name in the title of these files that you're sending me. Now, also between now and then, you'll have plenty of opportunities to still ask questions by email. And of course, I'll see you all again on Tuesday anyway, and Friday for that matter. So if you're stuck, if there's something about it that's not clear, you can just let me know. But basically, it's very much like what we're going to do right now. Okay, in other words, it'll be the same content. And so if you're okay with the sample midterm, you should be fine with the actual midterm. All right, so let's take a look at these questions. Now, some of these you do need a graph, and some of these you don't. If it doesn't specifically ask for a graph, you're not required to do one. But often I find that it helps a lot in working out the solutions if you have a graph, rather than just trying to remember what you're doing. All right, so let's start at the beginning. What is a complement? Well, now since these are English questions, there's a lot of ways we can express this. What I just want you to make sure that you mention is that a complement is a good that is consumed with another good. Okay. Now, it doesn't ask you for an example, but I'm going to give you one anyway, just so you remember what this means. For example, hamburgers are complement, or actually, we could say it this way: ketchup is a complement to hamburgers. All right. So again, that was not mandatory. I only put that in there just to help you remember what this means, but it didn't ask for that. So that wasn't absolutely necessary. All right. Anyway, a normal good. Well, you can give me examples, but if it doesn't specifically ask for one, it's not mandatory. All right. I like examples. In fact, I encourage you to give me examples, but if it doesn't ask for one, you don't have to give me an example. All right. Now, it might come along, and instead of saying, what is a complement, it might say, what's an example of complements, or something like that. And that's great. But if it doesn't specifically ask for one, then it's not absolutely necessary. Although I do think it's a good idea. All right, anyway, a normal good is one for which demand increases when incomes rise. Okay, that's all you need to know. As long as you buy more of this product when your incomes go up, that means it is a normal good. All right, now this is a tricky one. The difference between a change in demand and a change in quantity demanded. So for this one, you might want to even draw a little picture. A change in quantity demanded represents a movement, or is a movement, along the demand curve due to changes in the price of the good. Okay, whereas a change in quantity demanded is a shift of the entire demand curve due to a change in a factor other than the price of the good. It could be literally anything else. The price itself, if the price changes, we just move up and down the same curve. We call that a change in quantity demanded. If anything else changes, the entire curve has to shift, and we call that a change in demand. And that's because the entire relationship between price and quantity has been altered. All right, so just to quickly remind you how this works, you could think of this as a change in quantity demanded and over here, a shift of the curve in either direction. Let's say this is D2, this is D3. These are both examples of changes in demand. Okay, there's two possibilities in that case, an increase or a decrease. We'll call these changes in demand. How about that? To indicate that it could be either or. It could be an increase or a decrease. All right, that's the key difference between the two. And of course, once again, what's causing them is that the price changes. In the first case, the second case, any factor other than the price changes. Okay, let's see if I can sneak this all in here. There we go. Perfect. All right, that's all you need. And again, drawing those graphs is nice, but it's not mandatory. All right, now, because it didn't ask for one, how about this next one? What is the relationship between quantity supplied and quantity demanded when there is a shortage of a good? Okay, so when there is a shortage of a good, this means that the quantity demanded is greater than the quantity supplied. Again, you don't have to draw a picture because it doesn't ask for one, but I'm going to anyway, just because I want to remind you what this looks like. So of course, here's our equilibrium. I'll call this P star, Q star. And with the shortage, for whatever reason, the price is too low. Let's say it's here. I'll call it PL for P low or something like that. And you can see that the quantity demanded is greater than the quantity supplied. And the horizontal distance between these two is the size of our shortage. Okay. That's what it means to be short. The price is too low. People are buying up the entire product and then some. You go to the store and the shelves are empty. And that means we have a shortage. And the reason is typically because the price is below equilibrium. All right, people are willing to pay more for this product than you're currently charging them. Now, what happens to the price of a good when there's a surplus? Okay, so this is the opposite situation. When there is a surplus of a good, the price falls. Okay, now that's the answer, but again, let's try to figure out why. Because this is the opposite case where the price is too high. All right, here's our equilibrium price. P star, Q star, we'll call it. And let's call this pH for price that's too high. How about that? All right. So you can see from looking at this, the quantity supplied exceeds the quantity demanded. And the consequence of that is that the producers will recognize this and they will therefore lower the price until we're back in equilibrium. I mean, they can see for themselves that the product is not moving as fast as it should be. And so they realize that their mistake, they lower the price, and then everybody's happy again. Okay, they won't just leave it there because it's going to cost them money to keep building more of the product than they're supposed to. And of course, you remember, these are profit-making companies that we're looking at. They know that their survival depends on charging the right price, among other things. And so they're going to be very, very quick to make that change if it's necessary. Now, if technology improves, what happens to the supply curve? All right, well, improving technology reduces the cost of production, so the supply curve shifts to the right. Okay, in other words, anything that makes it more profitable to produce your goods and services is going to result in the curve shifting to the right. Okay, so, and again, it doesn't ask for a picture, but I'm going to give you one. Okay, because it's now more profitable to make this product, given that the costs of production are lower. Very good. All right, what's next? So with 7, which of the following increases the demand? Now, these you've got to really be careful with. It's so easy to get confused with these. Which of the following increases the demand for a good? A decrease in the price of a substitute or a decrease in the price of a complement? All right, so what you should probably do this. Think of examples, all right? So suppose we have Coke and Pepsi. If the price of Coke rises, sorry, it says decrease. Okay, if the price of Coke decreases, the demand for Pepsi will fall. So clearly that's not the right choice, is it? Okay, what about, how about, I don't know, French fries and ketchup? If the price of French fries decreases, the demand for ketchup will increase. And that's because people want to buy more fries, which means buying more ketchup as well. So the correct answer is a decrease in the price of a complement will increase the demand for a good. Okay, so like I was saying, that this particular case, I find that it's so easy to get confused. So your best bet is probably to make up an example. Okay, and if you say to yourself, well, I don't remember, I don't understand how this works, with this example in front of you, it should be much easier to reason it out. Okay, if you didn't make the examples, it's easy to get it wrong. So again, while it's not necessary, I really think it's a good idea. All right, does that make sense to everyone? Good. All right, now 8. What is the sign of the income elasticity of demand for an inferior good? All right, this is a very simple answer. Negative. All right. It's just as simple as that. With the income elasticity of demand, we're focused on the sign, and negative means that it is an inferior good, because it means that when you have more income, you're going to buy less of it. Okay, so I'll just put that in parentheses here. When our incomes rise, we buy fewer inferior goods, and vice versa. Okay, so that's the reasoning behind this, but the answer is negative. Okay, now the normal goods are classified as necessities and luxuries. And just as a quick reminder, in this case, the income elasticity of demand is between 0 and 1. And again, it doesn't ask for this, but I'm going to tell you anyway. Here, the income elasticity of demand is greater than 1. But they're both considered to be normal because they're both positive. The income elasticities are positive, but what we're basically doing is subdividing it into 2 categories: necessities, which are the ones that you buy on a regular basis, and the luxuries. Now, how about this one? Again, this one can be potentially very confusing. Sign of the cross elasticity of demand between 2 complements. Okay, so once again, let's use French fries and ketchup. So just to make sure that you don't make a mistake, so therefore, if the price of fries rises, the demand for ketchup will fall. Okay, so therefore, the cross elasticity of demand is negative. Okay, because remember what it is: the cross elasticity of demand equals the percentage change in the quantity demanded of good X due to a percentage change in the price of good Y. All right, so here you can think of X as the ketchup, Y is the French fries. Okay, so because the price and the quantity demanded go in opposite directions, that implies that the cross elasticity has to be negative. All right, or you know what, you can just memorize it too. There's a chart in the slide somewhere that will show this to you, but if you just want to reason it out, the best way to do that is with an example. And of course, you can do it both ways. You can reason it out and then check your notes. But it's good to really, the more you understand it though, the less likely you are to forget. Okay, it's easy to forget if you've memorized this, but if you understand it, then you will never forget it. Now, here's an interesting one. The price elasticity of demand for good is 1.2. What happens to total revenues if the price increases? So the demand for this good is elastic. People are very sensitive to price changes. Okay, so what you can do here is make up your own example. For let's say that initially is it's $10 and the quantity demanded is 100. Now the price elasticity is 1.2. If the price rises by 10%, the quantity demanded will fall by 10% times 1.2, which is 12%. As a result, the new price will be $11 and the new quantity demanded will be 88. Because 88 is 12% less than 100. The original total revenue, actually, let me do it this way. I'll put it up here. The total revenue is 10 times 100, which is 1,000. If we have the price increasing by 10%, the quantity demanded will go down by 12. Now that by itself should be enough to tell you that this was a mistake, but let's just prove it mathematically. The new quantity, the new total revenue is 11 times 88, which is 800 and, hold on. $968. Oops. So therefore, as a result of the price increase, total revenues have fallen. Now, again, you don't have to go through all the trouble of making up your own numbers, but it should be clear that when the elasticity is high like this, the response to a change in prices will be very significant. In fact, more than proportional to the change in the price. So an increase in the price of 10% will result in people buying 12% fewer units of this good. And so the result is that you have to lose money. So total revenues, the answer to the question is total revenues will fall when the price of when the price of a good with an elastic demand increases. Okay, in other words, don't do it. Don't raise the price when the demand is elastic. It's not a good move. All right, now, what is the price elasticity of demand for a vertical demand curve? So this is one of those weird cases that we saw. There were three weird cases. Well, I shouldn't say weird, but extreme cases. Vertical, of course, means this direction. Here, the price elasticity is 0. Now, if you forget, you know how you can reason it out. The price elasticity of demand is the percentage change in Q over the percentage change in P. But if you look at this curve carefully, Q never changes, which means that the percentage of change is also 0. And therefore, this ratio has to be 0 as well. That's why this is happening. Okay, now this is another interesting case. And again, we did see this downward sloping linear demand curve. What we're saying here is that at the midpoint of this demand curve, the price elasticity of demand equals exactly 1. Now that's, of course, taking the absolute value. It's really -1, but we'll call it 1. All right, so you might remember. And of course, in case they ask, or in case I asked, it goes up as you move up towards the upper left-hand corner. And it declines as we move down in this direction. Okay, but what the question wanted to know was the mid. So the answer to this question is the midpoint, which basically means halfway along the X and the Y coordinate axes. In other words, let's say that, let's put some numbers on here. Let's say the vertical intercept is 10. That means this would be 5. And let's say this is also 10, then this would be 5. That's the midpoint, where price is 5 and the quantity is 5 as well. All right. Now, does the availability of close substitutes for a good increase or decrease the price elasticity of demand? Well, the answer is it increases it. Okay, and it makes sense. I mean, when you think about it, this is because consumers have more choices and are more likely to switch when the price of a product changes. All right, in other words, if you go to the store and they've got 18 different soft drinks to choose from, well, you're probably going to pick the one that has the lowest price, or at least you're more likely to. Whereas if there's only 2, Well, you may be willing to overlook price changes because let's say you don't like the second one. You really are stuck with the first one. So the more substitutes there are, the more sensitive you'll be to changes in prices. The more choices you have, the more particular you'll be about what price you're willing to pay. All right. Now, if a change in the price of the good does not affect total revenues, what is the good's price elasticity of demand? Okay, that's that really bizarre case, which we saw. Okay, this is the case where the demand is unit elastic. Along the entire curve. Remember, we said that this is a hyperbolic demand curve, which describes the shape. And so what that means is the quantity, the total revenue is the same at every point on this demand curve. So the price elasticity of demand is 1 at every point on this curve. Okay, so in this case, it doesn't make the slightest bit of difference what price you charge. You're always going to wind up with the same revenues. Now, whether this can happen in practice is a very different question, but if that is the way this demand curve works, then literally the total revenue is identical at every point in that curve. I guess people want to spend a certain amount and that's it. It's hard to imagine an actual situation like that, but remember, this is one of the extreme cases. All right, very good. Now I think we're ready for some problems. Why, yes, we are. Okay, here we go. Now, starting from a position of equilibrium, state whether each of the following is caused by an increase in demand, a decrease in demand, an increase in supply, or a decrease in supply. All right, well, you know what? Again, this is one of those cases where it doesn't say you must draw a diagram, but I think it's a terrific idea. So in the first case, both the price and quantity went up. So if you remember, let me just give you a little hint here. When there is a change in demand, the price and quantity either both increase or decrease, or both decrease. When there is a change in supply, the price and quantity move in opposite directions. That's a hint. Why am I giving you this hint? Because I want you to recognize that the first two, the first and the last ones, both equilibrium price and quantity increase, they both decrease. A and D must represent changes in demand. B and C must, there's two B's here. B and C must represent changes in supply. The question is, which change? Is it an increase or is it a decrease? So for A, we're going to guess quite correctly that this increase in both must come from an increase in demand. All right. Now, if that didn't turn out to be right, you could just try it again. You could draw another picture until you come up with the right one. So let's try the increase in demand. So if we do have an increase in demand, maybe that's too much of an increase. Let's try this. You can see, what do you know? And this is exactly what we were hoping to see. All right, remember in part A, they're asking you what causes an increase in both the price and the quantity. So these are caused by an increase in demand. And of course, remember, increase, the word increase indicates a rightward shift. And that's true for both the demand and supply curves. All right, well, that's that one taken care of. Now, what about the next one? Okay, so now we're looking for the case where, oh, that's number 2. Hold on. You know what? Oh, I see what I did. Okay, let me move these down here. Equilibrium price increases, equilibrium quantity decreases. So right off the bat, because they're going in opposite directions, we know that there's been a change in the supply. But we don't know yet whether it's an increase or decrease. So because the price is going up, why don't we try the case where the supply curve is shifting to the left? If that's wrong, we'll try the other case. All right. And when we shift it to the left, oh, I think we are correct. Look at that. All right. So what we're seeing here is that the price did in fact go up. The quantity went down. And this was caused by a decrease in supply. Right? So you proved it. All right, just by drawing that picture, you've proven that a shift to the left of the supply curve will cause the price to go up while the quantity drops. All right, now in part C, C is the exact opposite of B, by the way. The price goes down and the quantity goes up. So we know already that this refers to an increase in supply, but let's just prove it with a graph. Okay, so let's shift the supply curve to the right and see what happens. So the price went down, the quantity went up. This is caused by an increase in supply. All right. All right, and then finally, both the price and quantity decrease. That's the opposite of the first case, which implies that the demand curve must have shifted to the left. right. So let's fill that one in. All right, good. And we're getting some good artistic practice here too, aren't we? I hope you're practicing with these curves. So if we do shift the demand curve to the left, you can see, yeah, both of them go down. All right, yes, they both went down. And this was caused by a decrease in demand. And so those are done. Now this one is different because this one actually says show graphically. That means you must provide a graph. So they're asking you to see what happens when there's an increase in the price of a complement. Now, again, you might want to think of an example. So what is the impact as an example? What is the impact on the demand for ketchup if French fries become more expensive? So again, if you're not sure how this works, you can try to memorize it, and that should work too. But I mean, I think it's easier if you just sit down and think about what's really happening. So we're looking at the demand for ketchup, and we discovered that for some reason potatoes have become far more expensive, which means fries are more expensive. And so our reaction to that will be to buy fewer French fries as well as less ketchup. Once you've got that part straight, the rest is easy. You're just drawing the same picture that we've drawn many times before. By now, you should be really good at this. Okay, so the impact is that the price drops and the quantity goes down as well. All right, now, whoops, what happened? Anyway. All right, well, I guess it's showing, it's still showing. There's a website behind it for some reason. We're just gonna knock that out of there. All right, anyway, so what about B? We expect the price of the good to fall in the future, okay? And again, not that you have to do this, but for example, if we expect iPhones to go on sale in the fall, you may decide to buy fewer iPhones now and buy more when they go on sale. Okay, so what does that have to do with anything? The demand for iPhones today therefore decreases. And the demand curve shifts to the left. All right, so once we get that part straight, just think about it in terms of, yeah, you know what, I've always wanted an iPhone. It looks like they're going on sale this fall as they clear out their inventory, waiting for the next one to come out. Why don't I wait and buy it then? Today, whereas maybe I was going to go to the store and buy one, now I've decided not to. So the demand in the entire market is going to go down. All right, we expect to save if we wait a little longer. So therefore, we postpone our purchase of that iPhone, and today's demand curve shifts to the left. Okay, so the demand curve shifts to the left. And as a result of our expecting the price of the good to fall in the future. Okay. All right. So that means there's shifting to the left of the demand curve, and as a result, the price and the quantity both drop. Now, how about this one? This is now the perspective of the producer. So automatically we know that this has something to do with the supply curve. So if the producer of the good expect the price to fall in the future, they would like to sell more today while the price is still relatively high. Therefore, the supply curve will shift to the right. Okay, so now again, you didn't have to do that. I just wanted you to see the reasoning behind a shift to the right of the supply curve. All right. So the supply shifts to the right. We try to sell more output today while the price is still fairly high. And so this is the result. All right. So what about D? Input prices decline. All right. This has to do with the supply curve because this involves the cost of production. So since the costs of production have declined, producing the good is now more profitable and more will be produced. Okay, in other words, the supply curve will shift to the right. Right? So it's the same outcome. A shift to the right of the supply curve will be the result of this case. Okay, so that's our final result, a shift to the right of the supply curve. All right, now what's coming up here? We're looking at the price elasticity of demand. Okay, so these are actual numerical calculations. And in addition, we have to identify each case as either elastic, unit elastic, or inelastic. All right, so formulas. So here's what you have to do in these cases. Identify P1 and P2. So the coffee will goes from $10 per pound to 11. The quantity demand, now when you see millions like this, don't worry about the millions, just write it as 50. Now, you might recall the formula. The official formula is a little bit different than the one we've been using. We're using what amounts to an approximation because of that problem we have where moving up and down the curve causes these numbers to be different depending on where we start and where we end. So we're using a formula for what's called arc elasticity, which means that it's essentially an average of the elasticities across those 2 points. And so formally, it's written like this. You've got the change in Q over the average value of Q, all divided by the same thing for P, but I think as you've seen before, algebraically, you're less likely to make mistakes, I guess, if you rewrite it like this. Okay, now just plug in the numbers. Okay, so we've got 48 minus 50 with the prices. That's our average, and the difference is here. So probably what you should do is break it up in pieces. In other words, solve each one separately and then plug them back in. So I'll have -2 over 49. Here we'll have 10.5 and 1. And you're guaranteed to get a negative number, which we will ignore, basically, the negative sign. So basically, this reduces to 21/49. Let's see what that is. Negative, let's say 0.43. It's actually 3/7. Okay, the bottom line here, though, is this. They want to know not only the elasticity, but we want to classify it. We have to specify whether the demand for this product is elastic, inelastic, or unit elastic. So how do we do that? Well, ignoring the sign. So first, the price elasticity of demand is negative 0.43. Or you can write it as 0.43 because we are ignoring the sign. And so because the elasticity of demand is less than 1, the demand for this product is said to be inelastic. Okay, so you can write it down as negative 0.43 or positive. Either way, we know that we're ignoring the sign. But when it comes time to determine if it's elastic or not, you're comparing the absolute value with 1 to determine what kind of elasticity we have. All right, so because 0.43 is less than 1, that implies that the demand for this product is inelastic. It's less than 1, it's inelastic. My fault, inelastic. Now, let's try this one. So again, you can ignore the millions. They would all cancel out anyway if you put in all those zeros. It just makes it a lot messier. So the price of the tickets goes from 100 to 110. And quantity demanded drops as a result from 3 to 2 million. All right, well, of course, we're going to use the same formula. Okay. And you notice I went directly to this version of the formula. Yeah, this one. I just think it's a lot easier to deal with it. Well, now look how easy it is to plug in these numbers. So we've got 2 minus 3 over 2 plus 3 over 2. And then here we have 110 plus 100 over 2, all divided by 110 minus 100. All right. Oh, wait a minute. Oh, I just realized. I'm sorry. I copied it wrong. The second Q is not 2, it's 2.7. All right, let me fix that real fast. That's better. All right, so in other words, it's 2.7 minus 3. Okay. Now we just do some calculations. So we'll have negative 0.3 over, now the average of 2.7 and 3 is 2.85. And over here, the average of these two is 105. And down here we have 10. All right, so if you multiply across, you get 31.5. And down here, of course, you get 28.5. And so that ratio is approximately equal to negative 1.105. Or you can express it as 1.105. And therefore, because the price elasticity of demand is greater than 1, the demand for this good is elastic. Okay, that's all you need to know. Where does it stand compared to 1? All right. Not bad. So I'll give you a minute to catch up. And then in the next section, we don't really have to do so many calculations. We just have to reason it out. All right, let's go on to this one. In the following cases, what will be the impact on total revenues? So now here, the demand is inelastic. People are not extremely sensitive to the price of this good. Okay, so that's like sort of like a hint. So it turns out that if the price increases by 10%, the quantity demanded will only fall by 0.8 times that, so that total revenues will increase. So I think that's the best way to think about it. You send up the price, increase the price by 10%. Clearly, people will buy less of this product, but only 8% less. So therefore, the on balance, you'll have more revenues. The price increase was more than enough to offset the reduction in quantity. Now, when the price elasticity is 1.2, the demand is elastic. People are extremely sensitive to the price of the good. Now, this is just for your own benefit. You don't have to include this in your answer. If the price increases by 10%, now here you can see the problem. The quantity demanded will fall by 1.2 times that, which is 12%. Therefore, total revenues will fall. So here we goofed. We raised the price for people who are very sensitive. So we'll gain 10% in the price, of course, but we'll also lose 12% in the quantity that we sell. And so on balance, we'll lose revenues. Now, finally, we have this oddball case. The price elasticity of demand is exactly 1. Demand is unit elastic. This means that when the price changes, the quantity demanded changes by the same amount in the opposite direction, so that total revenues do not change. Okay, so in this case, for example, if the price falls by 10%, the quantity demanded will rise by 10%, so that the total revenues will not change. Okay, so all you really need to do is say that the total revenues do not change, but I like the idea that we have all this extra explanation here. All right, I believe we are done. Yes, that was all of it. So I'll be posting these solutions later on today, and you'll be able to study these. And I'll also post the actual test so you can get started on it. And I think you'll be pleasantly surprised to see how straightforward it is. So very much just like what we just got through doing. So in the meantime, we have just a little bit of time left, not much, just enough to remind ourselves what we were doing last time, which was last Friday, which is to say we're still looking at this discussion about government interference in the market. And so far we've looked at 3 cases. Actually, no, only 2: rent ceilings and price ceilings, price floors. We looked at a video which explains how taxes work, but we haven't actually gone over that material ourselves yet. So we're going to look at some of our own examples of how taxes impact the market. Now, in general, taxes can help either increase consumer surplus or producer surplus, but typically, if one of them increases, the other decreases by a larger amount. And so we typically see with taxes that we have dead weight losses, just like when we had rent ceilings and price ceilings and price floors. Anything that interferes with people's choices is realistically going to result in dead weight loss, because people are forced to make decisions other than the ones that they really wanted to make. Like the people with rent ceilings who are unable to find apartments, that kind of thing. Well, let's jump down here now. With a tax could in principle be imposed directly on the sellers or directly on the buyers. So we'll start by considering what happens when there's a tax on the sellers. The tax on a seller is a problem because it increases the cost of production. So if imagine that you're McDonald's and suddenly the government decides to slap a huge tax on beef, that's going to cause a problem for McDonald's. Their cost of production will go up. And so they will probably end up losing money. And then on top of that, prices will go up for consumers. So it could end up harming both consumers and producers while producing some tax revenues, but probably not enough to avoid dead weight losses. Now, of course, in recent years, we've seen this with the cigarette market. I forgot when it happened, but several years ago, all of a sudden, the government just went berserk with taxes on cigarettes. They suddenly imposed an enormous tax on producers of cigarettes. And almost overnight, the price of a pack of cigarettes went from something like $2 to $10 or $12. I have no idea what they sell for now because I don't smoke, but I know that they're much, much more expensive than they were even 10, 15, 20 years ago. And it's primarily because of these taxes. It has nothing to do with tobacco. Apparently, tobacco growing is not any more difficult than it ever was in the past. But the issue here is with all the taxes. So the question is, how does this work? And who ends up paying the tax? Now, under most circumstances, the tax is shared by the seller and the buyer. In other words, when you walk in the door, let's say, for example, the government imposes a $10 tax on cigarettes, and you go into the store and you notice the price has only gone up by $9. That means that the seller has absorbed some of the cost of the cigarettes in order to maintain their market share, which does happen. They may decide that rather than pushing the price up by the full $10, they're better off pushing it up by only $9 and avoid losing too many customers. So that will depend ultimately, as we're going to see, on the elasticity of demand for that product and the elasticity of supply of that product. So in other words, here the impact suddenly depends on elasticities. That wasn't true before. The government just imposed a maximum minimum price, and we saw the impact on the existing supply and demand curves. This is different. A tax will affect either the supply or the demand curve, and in addition to that, the final burden of the tax will ultimately depend on elasticities. All right, so let's take a look at this first case. Let's say that in the market for cigarettes, the equilibrium price is $15 million. The price is $15, and people buy 10 million packs of cigarettes. Actually, the interesting thing is it just suddenly occurred to me that another thing that's changed over the last 10 or 20 years is not just the taxes, but the sudden existence of substitutes, those vaping things that I'm not even sure what they're, any of the details. All I know is the word vaping or vape means that you're smoking these special phony cigarettes that are actually producing, I don't know. I don't know what they do. Does anyone know what those vape things do? No? Okay. That's right, but you've heard of them. It's a substitute for cigarettes, but the smoke that comes out of it is different somehow. Let's go to the beginning here. What is a vape? Okay. Inhale and exhale vapor containing nicotine and flavoring. Oh, here we go. Somebody knows. It's a chemical. Okay. Produced by a device designed for this purpose. I'd rather people vaped indoors than smoke outside. Well, that's here we go. They use a battery to heat up a special liquid into an aerosol that users inhale. It is not just harmless water vapor. The e-juice that fills the cartridges usually contain nicotine, propylene glycol, flavorings, and other chemicals. I see. But I mean, I wonder, what I really wanted to know is how long have these things been around for? Not long. No. as early as 1963. Oh my God. Oh man, I thought they were invented like 5 years ago. Um, Jesus. Well, anyway, but the bottom line is you didn't used to see them anywhere. I mean, I never heard of them until just fairly recently, but that creates a substitute for cigarettes, which also has an impact in this market. But here, let's just assume that there are no alternatives for people who want to smoke. Either you smoke a cigarette or you don't smoke at all. Let's just assume that that's what's happening here. Now, as you can probably tell, the elasticity of demand for cigarettes is quite low. In fact, we could probably go find an estimate of it on the internet. Oh my God. Point. Oh, it's wow. It's actually higher than I expected. 0.87 without the sign. It's only just slightly under one. Wow. Man, I'm kind of surprised. And of course, the reason for that is because, as you know, I mean, cigarettes are addictive and people find it hard to give them up. And so I honestly would have thought the elasticity would be even lower than that. But the fact that it's below one means that when taxes are imposed, smokers are more likely to pay the tax than the producers, or at least a larger percentage of it. That's what this is all about, because they want the cigarettes and they're willing to pay more. So having a tax means that, yes, they'll pay more, but they may not necessarily cut back a lot. So let's just say in this example, the government imposes a lump sum tax of $1.50 per pack on the producers. In other words, they say to the companies that make the cigarettes, for every pack that you sell, you'll send us a check for $1.50. Okay, fine. Now, that means it's suddenly become much more expensive to make cigarettes. And so, let me move this where you can see it. The supply curve, as you can probably imagine, shifts to the left. Now, here's the interesting part, though. Initially, the equilibrium price was $15. Where is it now? It only went up to $15.50. Now, what happened? The tax is $1.50, and yet the market price only went up by 50 cents. And by the way, if you notice here, this vertical distance between these two can tell us that while the sellers are collecting $15.50 a pack, look what they have to do. They have to pay the $1.50 tax. So their net revenue from each sale is now only $14. Ooh, so consumers will pay $15.50. So you can see altogether, the sellers are receiving $1 less. The consumers are paying 50 cents more. So that means that of the $1.50 tax, consumers pay 50 cents. Producers pay $1. So interestingly enough, you might think that, well, if there's a $1.50 tax, it's going to come out of the pockets of the producers. And most of it did. But a full third of it was paid by the consumer. Now, why? Because the demand for this product is relatively inelastic. And the consumers, well, you see that the consumption fell from 10 to 9 million packs. There's still 9 million people out there who are willing to pay $15.50 for a pack of cigarettes. And so therefore, at least some of the tax was paid for by the consumer. Not all of it was paid for by the producer. Now, if the elasticities of these sellers and the buyers had been different, we might find a situation where the producers pay even more of the tax, or in some cases, they might pay less. It depends on the specific circumstances. So we're going to see several examples here that in some cases, the sellers may pay a larger percentage, and in some cases, they may pay a smaller percentage. In a few extreme cases, one side or the other may pay the entire tax. So now this is a fairly complicated topic. So I think that what we might want to do here is maybe call it a day. Yeah, it's time. All right, let's stop right here. So at least you know what we're doing in this section of the slides. So between now, well, actually, all you have to do is well, download the midterm when I post it and take a look at it and start working on it. You can have a week to do it. And in the meantime, just, flip to the slides and make sure you understand what we've been doing so that on Tuesday, we'll just carry on with chapter 7. All right. So, all right, I guess if there's no last minute questions, I'll see you all on Tuesday.
Thank you.
You're welcome. You're welcome. Bye. See you later. You're welcome.